All right, so this video is going to go over the mean, median, and mode of two different arrays or lists of numbers. And so I already set up, let me make sure this is loud enough. I already set up, close that. I already set up the main, and so I'm just going to kind of slowly scroll down. I've got it commented out because I'm going to do each one at a time for you guys, and you guys can see it run properly. But you know, if you want to write this at home, you can go ahead and pause this right now and just type out your main code. Basically what I'm doing is I've got a set mean for numbers 1, a set mean for numbers 2, a get mean for the number 1 and get mean for number 2 right here. And then I've got a set median, get median, set median, get median, set mode, get mode, set mode, get mode. And so I'm just doing the different arrays up here, okay? So so to figure out the median is just the average of the numbers. So let's go in here and look at this. Now, the mean is the easiest one to figure out. The other two are fairly complicated. So I'm just going to create my variables that I'll need. I got public void, we'll say set mean, and we need to pass in the numbers. And now, so I can pass whatever one on here, but when I accept it, it's just going to be called numbers, okay? So then we could do public double get mean, and we'll return the mean, okay? So we'll say sum is equal to 0 here, and mean is equal to 0, and we'll do a for loop. This one's the easiest one. We just need to run through each of our numbers and add them up and then divide it by the length. So we'll say int I equals 0. I is less than numbers dot length. I plus plus. Sum plus equals numbers at position I. We'll say mean equals sum divided by the numbers dot length. Okay, so you know, I can do this here too. We'll say this is the index. You know, 0, 1, 2, 3, 4, 5, you know, 6, and that's index position 7. This one doesn't have an index position 7. So anyway, we pass that in, and so the length of this one for the first one is going to be 1, 2, 3, 4, 5, 6, 7, 8. So we start at position 0. What's at position 0? It's 4. It gets added into sum. Then I becomes 1. Is 1 less than 8? Yes. So then what's in position 1? It's 2. 2 plus 4 becomes 6. And so sum gets added up. Everything gets added up. And then we divide that by the length of it to give us our mean. So if I run this, first one should work out. So number 1 mean 5.7. Okay. And if I cut that out and run that, you got 2 point, you know, and you could add these up if you want. So we got, let's just do the first one together. So So we got 30, 37, 40, 40, 46. So let me get the calculator. 46 divided by 8 gives us our 5.75. So I tested that. I know it works. And again, like I said, that's the easiest one. At bare minimum, you should know how to do these ones, okay? You should understand that. The next two are going to be hard, and the reason why I'm demonstrating this program is because you got a couple sorts that you have to do in your graded programs, and so the median and mode methods. The median and mode methods run sorts, okay? All right, so the mode, median's a bit harder. So to calculate the median, let's look at this. First thing you got to do, the median, let's see if I can do that. Okay, yeah. And I'm probably going to open up a notepad on this, okay? All right, so if that's my number, and let's do an index here. And there's a reason why I did two different numbers, because one's even and one's odd, okay? So the median, first thing you have to do is you got to sort this thing. So, in my mind, I can sort this. I can say 2, 2, that takes out those, right? But that's not how the computer, and then I'm just looking at it and go 3, 4, 5, 10, 10, 10, okay? That's not how the computer is going to work. The way that it has to work, okay, you're going to need nested loops. You have to compare this one to this one, okay? And check to see if they need to flip, okay? So, and then you would compare this, what's there at this one to the next one. Okay, so basically what it would do is it would do 2 and then 4 and then 3 and then 5, or it's going to put this here and then it's going to have to compare each of them. So let's start writing this in it, and then I can kind of show you what I'm talking about, all right? So public void set median. So I pass in the double numbers. All right, so we're going to say median equals 0, temp equals 0, values is going to be equal to the numbers dot length divided by 2. And I'll show you why that is in a little bit, because this gets back to, if it's ultimately the end sort of this thing is going to be 2, 2, 3, 4, 5, 10, 10, and 10, right? And so the values is half of this. So you would go 3 here, and you go 3 here. Well, if you divide this by 2, you get 4. What's in position 4? 0, 1, 2, 3, 4. Is this the middle number? No. You actually have to take these two and divide it by 2 to get the middle number, because there's 3 here, and 3 here. Remember, we have to do the middle. So you want to do an odd number and then an even number to kind of see how this works, all right? So let's kind of go through this. All right, so this is our sort, okay? And you're going to want to pay attention to this, okay? And I'm going to go through it, but again, this isn't the easiest thing. So let me write out the code first, and I'll explain it, all right? I wouldn't expect you to be able to write this in this course. Some of you might be able to. That's fine. But I would expect you to be able to read through this, though, by the end. Okay? Temp equals numbers at position I. Numbers at position I is equal to numbers at position X, and numbers at position X is equal to temp. All right, so that looks really complicated. Let's see what's going on here, all right? Let's see if I can shrink this so I can have both on the screen here. Okay, so this is our original array right here. So for I is 0, I is less than 8, okay? And then we have I is 0, 0 plus 1 is x, all right? So so what's at position I? It's 0, so that's 4. I messed something up. I didn't do an if statement, I think. Let's do this again real quick. If numbers at position I are greater than numbers at position X. This will make more sense now. I'm sitting here looking at it going, what? All right, so I is at position 0, and then X is going to be at position 1. So if whatever's at position 0, which is 4, is that greater than what's at position 1, 2? It is. 4 is greater than 2. So what I need to do is I need to store what's at position 0 into temp. So, you know, right here, temp would be equal to 4, basically, because, and I don't have an arrow to point to it, but that's position 0, and so that's going to be stored in temp, okay? Then next what we're going to do is we're going to store what's at, you know, numbers at position 0 equal to what's numbers at position X. So X, remember, is equal to 0 plus 1, which is 1. So that would be 2, okay? So what's happening here now is that what's at position 0 is now 2. So that gets taken away, and that's at 2 now, okay? And then what's at X? X is, remember, it's 0 plus 1. So what's at position 1? It's 2, is now equal to temp. So what's at numbers position 1 is equal to what's at temp, which is 4. So right here, this is now 4, okay? So we just swap those. We did something called a swap, okay? In order to do a swap, you have to have a temporary variable. You write the first one and blow out that data, but the temp variable was saved, and then the next one is going to be saved to that temp variable. So it swaps it, okay? Now that first inner loop is done, because remember, numbers is equal to 8, right? So then what happens here, X becomes, X was right here, 0 plus 1 is 1, so we add 1 to it, X becomes 2, okay? X is now 2 right here. So then we go, is what's at position 0, which is 2, right here, is what's at position 0, because I never changed. I is still 0. Is that greater than what's at position 3? No, it's not. And so that's not true. So we go back up here, add 1 to x. X becomes 3. Is what's at position 0, which is 2, is that greater than 5? No, it's not. So x becomes 4. Is 2 greater than 2? No, it's not. So it goes back up. Checks position 5. Is 2 greater than 5? No. And then is 2 greater than 10? 2 greater than 10 again? No, it's not. So after our first inner loop, this is what our new array looks like. Then what happens is 1 gets added to I. Is 1 less than 8? Yes. So then we do 1 plus 2. So I, in this case, is going to be equal to 1 right here. We're looking at this. I is 1. Is what's at position 1? Remember, we did 1 plus 1 is, or sorry, we did 2 plus 1 is 3. No. 1 plus 1 is 2. See, this is where it gets confusing for me, all right? So maybe it's best that I write down where I'm at in index position. So this first time through, I is 0, okay? So I'll come down here. I is going to be 1, okay? And then, so 1 plus 1 is now 2. And what's at position 1? It's 4. Is 4 greater than what's at position 2, 3? Yes, so we've got to do, that's true. So we do our temp. What's at position 1 is 4. And then numbers at position 1 is going to be equal to numbers at position 2, which is 3. Okay, so now this gets blown out, and that is now 3. Okay, and then what's numbers at position 2? That's equal to, that's going to be equal to the temp, which is 4. Okay, so now what's at position? So we blew out the 4 here, and we're swapping it right there. So now we got 2, 3, 4. So then what we do, so that ends that. We add 1 to x. X becomes 3. So is what's at position 1 greater? So is 3 greater than 5 right here? Nope. Is 3 greater than 2 right here? Yes. So then what do we do here? We do temp equals right here, which is 3. And then we do what? Numbers at 1, and we set it equal to the numbers at x, which is 2. So this gets blown out, and this is now 2. And numbers at position 4, that gets set to what's at temp, which is 3. So those get swapped, and that's a 3 right there. And then, in this case, 2 is then less than 10, and that's less than 10 and 10. And then so we go back up, and then I becomes 2. And we do this over and over again. We compare, we would compare this to this, and that wouldn't be true, so we wouldn't swap them. But then we compare this to this, and that would be true, so we would swap those. So this would become a 3, and this would become a 4. And then 3 compared to 10, and then 10, and then 10. We're done. So then we would get to here, and then we have to compare all these, and so then we would swap these, and we get 4 and 5, and we would swap those. And then pretty much that's the end of it, okay? But that's how that for loop works, okay? So we can do a test in here, test to see if the sort works properly. Okay, and we could say for if I equals 0, I is less than numbers dot length I plus plus, and we could do system dot out dot println, or just print, whatever, it doesn't matter. Numbers at I plus a blank. Okay, so if I run this, I got 2, 2, 2, 2, 2, 3, 4, 5, 10, 10, 10. Okay, so that's that. So we haven't calculated our mean yet. So I'm going to actually just comment that out. You guys can put that in to test your stuff. Okay. So now that we have it sorted, now the thing is we have to figure out if it's even or odd. So if numbers dot length modulus 2 is equal to 0, then we'll say our median is equal to, so if it's an even number, in this case, remember it's 8. If it's an even, there's 4 here and 4 here. Then we have to take this right here. We add them up and divide it by 2, so it would be 4.5. So 4 plus 5 is 9, divided by 2 is 4.5. So in order to figure that out, we would say, and remember I did this up here, 8 divided by 2 is 4, okay? But what's at position 4? That's right there, 5, okay? So we got to go back one to grab this, okay? So we would say, what? We would say numbers at the values minus 1 plus the numbers at the values divided by 2 and else we would calculate it as numbers. So if it's an odd number at values, so if we go back to this number right here, there's 1, 2, 3 here, 1, 2, 3 here. So 1, 2, 3, 4, 5, 6, 7. 7 divided by 2 is 3.5 in real life, but when they're numbers, you get 3 and you get 3, right? So 0, 1, 2, 3, that would be your number right there is 5. Even though it'd have to sort first, so it wouldn't be 5. So anyway, that's the median. So if I run this now, my median is 4.5, which that's what we went through. Now this one, let's think about this number real quick. Let's see what the median would be so we can just test it. Okay, so right here, if we have that, it would be 2, no, it'd be 1, 2, there's 3 2s, 2, 2, 2, 4, and then 5. So we get the median is, did I add an extra one there? What am I missing? A 3 here. So I got 1, 2, 3. So it'd be 1, then 3 2s, then a 3, 4, and a 5. So 2 is our median. Let's test it. All right, let's see here. Yep, and we get 2 right there. Okay. Now mode is the one that's used the most often, so we have to be able to count up the number. So we do something similar to median, but now we got to count the number of times it's used, okay? So, all right, so let's set this up for mode. Public void set mode. Again, we got to pass in our double numbers. All right, in here I'm going to create a couple variables. So mode, or I'm going to assign some variables. Mode is 0, count is 0, max count equals 0. All right, so we're gonna have the same for loop, nested for loop. So we'll say, and I think I'm just going to, well, it's gonna be just a little different here. I'm actually gonna set this to 0 here, because we want the first time through to actually count what variable we're on. All right, so we're gonna say, so basically it's kind of the same thing, okay? We're gonna, we can have our original number like this one right here. Let's just do this one for mode, okay? So we can have our original number. You don't have to sort anything, but what we're gonna have to do is we're gonna have to check this, and we're gonna have to compare it to this and see if they're the same. If they are, then we add up our count, because we're counting the most numbers used. So the mode on this one is going to be 2 because it's 1, 2, 3. So first time through, 0 is 0 equal to 0. Well, watch what we're going to do. I'll do that here. We'll say if numbers at position I are equal to numbers at position X, we count plus plus. Okay, and then what we're going to do after we go through each of these. So is 0 equal? What's at position 0 equal to what's at position? So is 4 equal to 4? Yes. So then we would count that one time. Okay. But then we would go through, and x would grow, then x would grow by 1, where I would be 0. So is 0 equal to the same thing that's at position 1? No. Is what's at position 0 equal to what's at position 2? No. And then this one, so no, it won't. So, but count would be 1 now, because originally count 0. So 4, after our first time through, is the mode, okay? Because we haven't been able to compare the rest of them. So 4 is our mode. So right here we would say if the count is greater than the max counts, which I showed you 1 is greater than 0, then we say the mode is equal to the numbers at position I. Sorry, not max count. Okay. And then our new max count is equal to the count. So max count is no longer equal to 0. It's equal to 1 now. Okay, because count was 1. All right. And then we can set our count back to 0. Okay, because now we got to compare the rest of them. All right. And then so we go back up. I becomes 1. Well, what's at position 1? It's 1. Okay, x is 0. Is what's at position 1 equal to what's at position 0? No. Then x becomes 1. Is what's at position 1 equal to what's at position 1? Yes. So count becomes 1. And then is what at position 1 equal to what's at position 2? No. So then is what's at position 1 equal to what's at position 3? No. And then 4, 5, nope. So count is 1. And so is 1 greater than 1? No, it's not. It's the same. So we don't do this. We don't assign a new mode. Our mode is still 4. And then count is 0. Okay. Then we would do this one, and we would do this all the way through till we get to here, and I guess it's best to explain here. So if our index, let me do this, scoot this over. So we would eventually get to this one, right? Where I is what? I is 4, or I is 2. The index. Sorry, I is 4, where the index is at, and it's It's position 2, or its element is 2. And so then is what's at position 4 equal to what's at position 0? No. Is what's at position 4 equal to what's at position 1? No. 2, no. 3, no. 4 is equal to 4. Yep. So that would be a count 1. Okay. And then we would have to go back up. Is what's at position 4 equal to what's at 5? Yes. That would be a count 2. And then what's at position 6? 4 equal to what's at position 6? Yes. So that'd be a count. We'd add 1 up to count. That'd be 3. And then is 3 greater than our max count of 1 before? Sorry, of our mode was 4, remember, the first time through? And 3 would be greater than 4. So then what our mode is now the numbers at position I, which is index position 4. So our mode is now 2, and our max count is now equal to 3. Okay? And then we set count back to 2 or to 0, and then we do it again for this one and this one. And for these ones, they would be the same thing as what was at position 4. So it would just do it for 5, for index position 5 and 6, and then we get our mode. So let's see what happens here. I think this works. So mode is 10. Yep. For this first one, mode would be 10 because 10 is the most used. And then if we get rid of this right here, so mode is 10 and 2. Okay, so it works. Again, I don't really expect you guys to write this in the principles class. This would be more like an A-level class. If you can do it, good job. I think you're probably ahead where you need to be. But I think it is important that you know how to read through, at bare minimum, you know how to read through it. Now, this kind of stuff is going to get you your 5 on your AP project. You're doing nested loops and algorithms. This is the kind of stuff that would likely get you a 5 on the AP test. So anyway, test this out and play with it and try to understand it, okay? And this video is done.